Welcome to Beyond the Prompt, the AI podcast, based on discussions of the Large Language Model Reading Group of the Leiden Institute of Advanced Computer Science.
Oh, always happy to be here.
Today we're diving deep
Okay.
into a research paper asks a kind of mind-blowing question. Can AI automate scientific discovery? It's called The AI Scientist, towards fully automated, open-ended scientific discovery. And let me tell you, it's got the whole AI community buzzing.
Yeah, it's a bold concept, that's
Yeah.
for sure. The paper lays out a framework for an AI system that could potentially handle the entire scientific process, from generating those research ideas to conducting experiments, analyzing data, and even writing the final research paper.
Okay, so for our listeners who might not be fluent in AI jargon,
Sure.
let's break this down. Imagine, like, you're a scientist,
Okay.
but instead of spending, like, hours in the lab, you have this AI assistant kind of working for you 24/7.
Exactly, and this AI assistant, it doesn't just fetch you coffee. It's actually capable of brainstorming new research ideas, designing experiments, running simulations, analyzing the results, and then neatly packaging all that into a scientific paper ready to be submitted to a journal.
Hold on, it writes the entire paper.
Yeah.
That's insane, like from intro to conclusion, the whole shebang.
That's the claim, and the authors didn't just stop there. They even developed a separate AI system to act as a reviewer,
Okay.
evaluating the quality and originality of these AI-generated papers.
So it's like AI peer review.
Yep.
That's next level stuff. But how does this AI scientist actually work? Like, where does it even begin?
Well, it all starts with a simple code template, kind of like a basic set of instructions for training a small AI model, like a mini version of what we use for language processing.
So it's not starting from scratch.
No.
It has some, like, foundational knowledge to build on.
Exactly. From there, the AI scientist uses a really clever approach inspired by evolution to brainstorm new research ideas.
Oh.
It generates a bunch of potential research directions, almost like mutations in a gene pool.
So it's like survival of the fittest for research ideas.
Yeah.
Only the strongest and most promising ones make it through.
That's a great analogy. The AI scientist evaluates these ideas based on two key criteria: novelty and feasibility.
Novelty makes sense. We want groundbreaking research, but how does it judge feasibility?
Right.
Does it have some, like, secret formula for predicting success?
Well, it's not magic, but it is pretty sophisticated. It takes into account things like whether the idea can be tested with available data and computational resources. It even checks if the idea has already been explored by searching a massive database of existing research using the Semantic Scholar API.
Oh, wow. So it's like a super-powered literature review,
Yeah.
making sure it doesn't waste time on ideas that have already been done to death.
Precisely. And once it has a handful of promising research directions, the AI scientist moves into the experimental phase. This is where things get really interesting.
So it's time to, like, put on the lab coat and get to work.
Metaphorically speaking, yes. The AI scientist uses a tool called Aider to actually write the code for the experiments. Aider helps debug errors, suggests improvements, almost like having a coding buddy by your side.
It's like pair programming for AI.
Yeah.
So once the code is written, what happens next? Does it just, like, hit the run button and hope for the best?
Not quite. It takes a much more systematic approach. It runs the experiments, meticulously collects the data, analyzes the results, and even generates visualizations just like a human scientist would.
It's like watching a mini-me scientist in action. But hold on, we're still missing a crucial piece of the puzzle here. How does the AI scientist actually go from, like, raw data and results
Right.
to a full-fledged scientific paper? That seems like the most daunting part.
It is a complex task, but the AI scientist has a surprising trick up its sleeve. It uses a predefined structure, like a template for scientific papers. This includes all the standard sections: abstract, introduction, methods, results, discussion, and even references.
So it's like filling in the blanks of a scientific Mad Libs.
Yeah.
But how does it know what to put in each section?
It uses the experimental logs, the data it collected, and the analysis it performed to automatically populate the relevant sections of the paper. It even knows how to format everything correctly using LaTeX, the standard typesetting language for scientific documents.
So it's not just spitting out random text. It's actually organizing and presenting the information in a coherent and scientifically rigorous way.
Exactly. And the authors of the paper claim that the quality of these AI-generated papers is surprisingly high. They even pass muster with the AI reviewer, which was trained on a massive data set of human-written scientific papers.
Okay, now my mind is officially starting to melt. We've got this AI scientist that can generate ideas, run experiments, analyze data, and even write the paper. What's left for us humans to do?
Well, before we jump to conclusions, let's remember that this is still early stage research.
Okay.
There are limitations to what the AI scientist can do, and it's certainly not going to replace human scientists anytime soon.
That's a relief. But I have to admit, I'm still a bit blown away by the potential here. I mean, if AI can handle the grunt work of scientific research, that frees up human scientists to, focus on the bigger picture, the really creative and groundbreaking stuff, right?
Absolutely. That's one of the most exciting prospects of this technology. It has the potential to accelerate scientific discovery, help us tackle complex challenges that have stumped us for years, and perhaps even lead to breakthroughs we haven't even imagined yet.
This is where it gets really interesting. But before we dive into the nitty-gritty of the AI scientist's capabilities and the potential implications for the future of science,
Sure.
let's take a quick detour and look at some concrete examples of the research papers it actually generated.
Okay.
Would you mind walking us through a few of the highlights, maybe focusing on the areas that really sparked discussion in the LLM reading group?
Of course, I'd be happy to. The AI scientist was tested in 3 different areas of machine learning, and it produced some truly fascinating results. We were particularly impressed with the paper titled Dual-Scale Diffusion, Adaptive Feature Balancing for Low-Dimensional Generative Models.
That's a mouthful. What does it even mean in plain English?
In essence, it tackles a common problem in AI image generation. Imagine you're trying to train an AI to generate realistic images of cats.
Okay.
You want to make sure it gets the overall shape and structure of the cat right, but you also want it to capture those finer details, like the texture of the fur or the glint in its eyes.
So it's like balancing the big picture with the tiny details. That sounds tricky.
It is, and that's where the AI scientist came up with a really clever approach called dual-scale diffusion. It essentially processes the image at 2 different resolutions simultaneously. It's like looking at the cat through a zoom lens and a wide-angle lens at the same time.
So it's getting both the forest and the trees, so to speak.
Exactly. And the results were impressive. The AI scientists managed to improve the quality of the generated images, making them more realistic and detailed.
Wow.
It even reduced a metric called KL divergence, which measures how well the generated images match the real data distribution.
That sounds like a win. So the AI scientist is not just churning out papers, it's actually producing research that could advance the field of AI image generation.
Precisely, and that's just one example. We also discussed another fascinating paper titled Style Fusion, Adaptive Multi-Style Generation in Character-Level Language Models. This one dives into the challenge of generating text with different writing styles.
So instead of just sounding like a generic AI, it can actually mimic the style of a specific author. Or genre. That's wild.
It is. The AI scientist was able to generate text that sounded remarkably like Shakespeare, Wikipedia articles, and even different types of fiction. It all comes down to a clever mechanism called a style adapter.
A style adapter. Is that like a fashion accessory for AI?
Not quite. Think of it as a way for the AI to learn the unique fingerprints of different writing styles. It analyzes massive amounts of text and extracts the subtle patterns that make each style distinct. Then, it can use those patterns to generate new text that matches the desired style. It's like giving the AI chameleon-like ability to blend in with different literary environments.
That's amazing. So the AI scientist isn't just a one-trick pony. It can tackle all sorts of challenging research questions across different areas of AI. This is starting to feel like a real game changer.
It is. But before we get too carried away, let's take a step back and consider some of the limitations and potential concerns that emerged during our LLM reading group discussions. The AI scientist is a powerful tool, but it's not without its quirks and challenges.
So there's a catch.
Yeah.
There's always a catch. What kind of issues did you uncover?
Well, one thing that stood out was the AI scientist's tendency to put a positive spin on negative results. In some cases, it would describe an experiment where the performance actually got worse as a marginal improvement or a step in the right direction.
So it's like the AI equivalent of a glass half full optimist.
Yeah.
That's kind of endearing, but also a bit worrying if we're relying on it for objective scientific analysis.
Exactly. It highlights the need for careful scrutiny and interpretation of AI-generated research. We also noticed that the AI scientists sometimes relied heavily on experimental logs in its writing, including raw data and code snippets that wouldn't normally be found in a polished scientific paper.
So it's like it hasn't quite mastered the art of scientific storytelling. It's still got a bit of a rough edge when it comes to presentation.
That's a good way to put it. And another limitation was the relatively small number of references used in the papers. This suggests that the AI scientist knowledge base might be somewhat limited compared to a human scientist who has years of experience and a vast network of colleagues.
So it's still a bit of a newbie in the world of science. It's got the raw talent, but needs a bit more seasoning and experience.
That's a fair assessment, but despite these limitations, we were all struck by the AI scientist's potential. It's a remarkable feat of engineering, and it raises profound questions about the future of scientific discovery.
This is where we need to pause for a moment and let our listeners digest all of this mind-blowing information.
Okay.
We've covered a lot of ground, from the basic mechanics of the AI scientist framework to the intriguing examples of research papers it generated.
That's right.
But the real conversation starts now. What does this all mean for the future of science? Will AI become our collaborators, our competitors, or something else entirely? We'll explore these questions and more when we return. Stay tuned.